Hi, I'm Mark. Welcome to Shark Files, the series where we dive into the fascinating world of sharks, skates, rays, and chimera. Today, we're taking a closer look at one of the most iconic features of sharks and rays, their teeth. Sharks have been around for over 400 million years, and one of the key reasons for their success is a dental system unlike anything seen in other animals. Sharks' teeth are also incredibly specialised. Different shapes, sizes, and arrangements tell us a huge amount about how a shark feeds and what it eats. So what makes shark teeth unique from other animals? Why do sharks lose so many teeth? And what can their teeth tell us about both modern sharks and the sharks of prehistory? Sharks lose a lot of teeth. But this isn't a flaw in their evolution, it's a feature. Unlike other animals, sharks' teeth aren't anchored deeply into the jaw, so if you look closely at their roots, you'll see that they're relatively short, and this allows them to break off easily during feeding. Sharks and rays have multiple rows of teeth, often described as a biological conveyor belt. When a tooth at the front is lost or damaged, the teeth behind it slowly rotate forward to take its place. This process happens continuously throughout a shark's life. Depending on the species, a shark can shed tens of thousands of teeth in its lifetime, with some estimates reaching around 30,000 over their lifetime. This system of constant replacement ensures that a shark is never without functional teeth. Not all shark teeth are the same. In fact, tooth shape is one of the clearest indicators of how a shark feeds and what it eats. So the two sharks, the blue shark and the Porbeagle shark, are a great example of how different tooth designs reflect different feeding strategies. Blue shark teeth differ between the jaws. The lower jaw teeth are long and slender, making them well suited for grabbing and holding slippery prey, such as fish and squid, whereas the upper jaw teeth are more triangular and serrated. These teeth are adapted for dealing with larger food items, including carrion such as dead seal and whale. Once prey is secured, the shark can bite down and shake its head, allowing the serrated upper teeth to slice through the flesh. This combination of grasping and cutting makes the blue shark a highly effective opportunistic feeder, capable of exploiting a wide range of food sources. In contrast, Porbeagle teeth are not designed for slicing. Instead, they are long, narrow, and sharply pointed, adapted for a single primary function, grasping agile prey, such as fast-moving fish. This tooth shape allows porbeagles to seize and retain prey efficiently, rather than cutting it into pieces. As discussed, the porbeagle's teeth reflect a feeding approach focused on capturing and controlling prey. But we only need to look at the white shark, a fellow mackerel shark, also known as a lamnid, to see how this changes. The increase in scale is immediately obvious. White shark teeth are far larger, more robust, and built to withstand extreme forces during feeding. This allows white sharks to process much larger prey items, including animals with thick flesh and blubber. But even this isn't the upper limit. Take this tooth from the ancient species Megalodon. At this scale, the comparison becomes striking. Megalodon teeth can exceed the size of a human hand and are among the largest teeth ever produced by a vertebrate. Their size indicates a predator capable of tackling very large marine animals, including whales. Unlike most animals, sharks don't have skeletons made of bone. Instead, their bodies are supported by cartilage, the same flexible material found in the human nose and ears. Cartilage doesn't fossilize well, which means the vast majority of sharks' bodies gets lost with time. Teeth are the exception. Sharks' teeth are coated in hard enamel, making them durable enough to survive long after the rest of the animal has disappeared. As a result, teeth are often only fossilized remains we have for many extinct shark species. This is why shark teeth dominate the fossil record, and why species like the Megalodon are known almost entirely from their teeth. Not all shark and ray teeth are used for biting. One of the most extreme and unusual examples comes from the sawfish. At first glance, the sawfish's long, flattened snout, known as a rostrum, looks like a weapon straight out of a science fiction. Along each side are a series of sharp, tooth-like structures, giving it the appearance of a living saw. But these aren't teeth in the traditional sense. The structures lining the rostrum are actually modified teeth, embedded directly into the cartilage of the snout. Sawfish use this rostrum in a sensory role, helping detect electrical signals produced by the prey. They then strike at the disturbed fish in the sand before eating them. Thank you for watching Shark Files. If you'd like to learn more, you can find additional resources, images, and more shark-related content on our website at sharktrust.org. And if you enjoyed this episode, make sure you subscribe to watch more Shark Files. Thank you for watching, and we'll see you next time.